let's touch base on what you may have forgotten. So, who found something that you have forgotten?
First problem.
Olivia. Number 2? Which one? Well, pick one. A. 2A. Find the exact value of the cosine of 120 degrees. Okay. So what do we have to do first? What do we always do? Draw a picture, right? Let's draw a picture of this. So 120 degrees. Remember, our angles always start here. 120 would look like this. This is 120 degrees. Remember, we start here always. 90, 180, so 120 is somewhere in between there. Now, I make a triangle. Remember your triangle, always make a triangle. And then you got to figure out this guy right here. So think about it, use your common sense. How big would this angle right here be? 60? Isn't it halfway around 180?
Yeah.
So if you've gone 120, this part's 60. And that's a 90, and that's a 30. What do you know about 30, 60, 90 triangles? They're special. Yes, they are special. What about their sides?
30 is
Root 3 goes across from the 60. 2 is the hypotenuse, and 1 goes across from the 30. Ay, 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 ay. Then we got to mark any negatives that might be in there. So what's negative? 1 is negative. And we know that because here's the origin. If you go that way, it's negative. Right? Now, what is the cosine? So ka-toa. So look at your triangle. What's the cosine? Negative 1 over 2. That's exactly right. This is the adjacent side. Here's your angle. This is the adjacent side. This is the hypotenuse. Cosine is also x over r. So if it helps you to think about it that way, x, this is the x-axis, this is the x number, and that's the hypotenuse. Now, Matthew, what?
Will we get these or no? Like it's
no, you're not going to get that sheet, no.
Okay.
You might get some stuff.
Okay.
And again, it's all about keeping Mrs. Ford happy, right? And bringing me lots of chocolate. Yep. Candy kisses. Mm-hmm.
Candy kisses.
All right, who else has a question? Found something we don't know how to do.
Can we do 1A?
1A. Simplify as much as possible. Okay. Well, there's lots of things to do in this problem, and really the order you do them doesn't matter. So who can think of something that needs to be done? Something we need to do. Okay, so that -2 right there goes to everything in the problem, right? So 3 to the -2nd, including the 3. So 3 to the -2nd, x to the 4. Because when you have a power raised to another power, you multiply. So then this is y to the -14 over 5 to the -2nd. You have to take, if you're going to distribute first, which is fine, you got to take everything to that power. So x to the -2nd and y to the 8th. Now, again, you do not have to start that particular way, but that's fine. It's absolutely fine to start that way. That needs to be done. You have to distribute at some point. All right, now what? We got a ton of negative action, right? We need to fix that. Negatives are not good. So, anything that's negative, anything with a negative exponent, anything with a negative exponent is going to move. So see that? He's coming to the bottom. That guy can stay right where he is because he's positive exponent. This guy's coming to the bottom. This guy's going to the top. He's going to the top. And he's staying right where he's at. Okay, remember that rule? When things have negative exponents, they move? Now, 5 squared is 25. What happens here? I have 4 x's and another 2 x's. I add them, and that'll be x to the 6th. Remember, when it was a power to another power, 1x, but 2 exponents, you multiply. When it's 2 separate x's, you add. All right, so on the bottom I have 9, and y to the 22nd. 14 and 8. Okay? Who else found something on this first review sheet that we need to do? Michael, is your hand up? Who else?
2C.
All right, we'll do 2C and then we'll do your problem now. All right, so cosecant 5 pi over 3. It's just like the one I'm erasing, except the angle is given in radians. That's a radian angle. So who remembers how to change that into degrees so we can work with it? Campbell?
W divide 180 by 3 and multiply by 5.
Pi is 180, right? Pi radians is 180 degrees. So pi divided by 3, so 180 divided by 3 is 60, times 5 is 300. So this is really saying find the cosecant of 300. Right? All right, so here we go. Where's 300? I'm going to draw my picture. 300 is all the way around, actually to here. Because every quadrant is 90. So there's 90, 180, 270. And if I went all the way around, it'd be 360. So don't I need to be somewhere between 270 and 360? All right, what did I do last time? I drew my angle, and then what did I do?
Triangle.
I made a triangle. Okay? Michael, what are you doing? What are you doing? Okay, you're looking in your phone to watch yourself do your hair in the middle of math class. That's not appropriate. Put your phone away. I want you to stay after class. I want to speak with you. All right, so 300 is here. I drew my triangle. Now, how big is this angle right here? 60. Everybody should be able to figure that out. There's no formula for that. It's just your common sense. All the way around is 360. I only went 300, so I've got 60 more to go. Now, that triangle is exactly the same as the other one we had up here. Across from the 60 is root 3, the hypotenuse is 2, and the short leg is 1. Across from the 30 is 1. Is anything negative this time? The root 3 is negative because it's down. Down is a negative direction. This is the origin. If you go down, you're negative. Now, when I memorize SOHCAHTOA, I know that sine is opposite over hypotenuse, right? That's sine. But this is cosecant. And I need to remember that cosecant is reciprocal of sine. So if the sine is opposite over hypotenuse, then the cosecant is hypotenuse over opposite. So hypotenuse over opposite will be -2 over root 3. What about that? Can't have it. So we'll multiply top and bottom by root 3. So -2 root 3 over 3 is the final answer to the problem. Okay? All right, who else found something as you were doing your, oh, Madeline, I'm sorry, yes, I promised you, yeah, which one?
4A.
4A. Now, there are a bunch of, I guess there's 2 algorithm problems on here. This one is a little bit, this one is the basic logarithmic idea, and that is, remember loop-de-loo? So we're gonna loop-de-loo this, and loop-de-loo says start right here with the bottom number, raise it to the third, and it equals x. So 4 to the third equals x. That's the basic loop-de-loo motion. Start with the bottom number, the base of the logarithm. Loop it over to here, so 4 to the third, and then equals x. So what's 4 to the third? The answer is problem 64. Yep. Yep, that's it, 64. Okay. Who else found one? Which one?
B, the 4B.
4B?
Yeah.
4B now is another logarithm problem, but this one's a little bit more, it's bigger. Does anybody remember anything about this? Okay, what you cannot do is cross out the logarithms. They don't cancel. You can't get rid of them. You're stuck with them, at least for now. The first thing we do is put these 2 together. So instead of having 2 separate logarithms, we're going to have 1. Do you remember how to put them together when it's a minus problem? It's a division. So this is going to be the log base 5 of x plus 3 over x. If that had been an add, they would go together as a multiplication. You guys must have a terrible teacher. I can't believe you don't remember that when you divide, or when you subtract logarithms, that means you're doing a division. When you add logarithms, that means you would be multiplying, but I'm not. Now, if the log of this, now I've combined those and made one thing out of them, it's a division. If the log of this equals the log of this, what do you think? Now you can set them equal. So now you can say x plus 3 over x equals 5. You cannot do that in the beginning. The only way you can get rid of these logarithms is if you have 1 on each side. So step 1 is put these together. Okay? Well, let's solve it. So x plus 3 equals 5x. Multiply that over there. Subtract x, so 3 equals 4x. Divide by 4, so x equals 3/4. So the answer answer to the problem is 3/4. Well, the good news is we don't take your exam for over a week. Bad news is you guys have a lot of reviewing to do. All right, we got 4 more minutes. Let's do a couple more. Who else found something? Who's talking? Ethan?
Wait, can we do, number 3 for, yeah, just number 3?
3. Does this thing represent growth or decay? What do you think? You may remember anything about this number 3. Does it represent growth or decay? It's kind of like our limit problems. See how that 0.73 is less than 1? That means the numbers are going to be going down, right? So the limit would actually be 0, but that means it's decaying down to nothing. So this is a decay problem. And it's exactly the same idea as with our limits. If the number being raised to the power is more than 1, it's growth. If it's less than 1, it's decay. So this is a decay problem. Now, the amount that it's bigger than 1 or less than 1 is the percent of growth or decay. So how much is 0.73 less than 1? 0.27? So this is a 27% decay. The amount that you are either more than 1 or less than 1 by is your percent of growth or decay. Okay, got it? And what is the initial value? Anybody remember that? 300. It's the number out in front. The number out in front is the initial value. Okay, now here's what I want you to do for next time. All right, I want you to look through